Now that we have downloaded, extracted and selected a piece of corona imagery, we are now going to georeference it in QGIS. To do this, first open the Georeferencer tool. Click Raster on the menu and Georeferencer. I'm going to dock the Georeferencer into QGIS, but you may not have room to do this. Next, make sure the project CRS is set to WGS 84. Now we have to configure the georeferencer. First, add the raster by selecting the Open Raster button or going to File, Open Raster and selecting your chosen image. And then changing the transformation settings by clicking the Transformation Settings button or going to Settings, Transformation Settings. We want Polynomial 1. We want WGS 84, the same as the project CRS. And you can click the Browse button next to Output Raster and give it a suitable name. I'm going to use the original name, but just add GR afterwards to show that it's been georeferenced. Make sure that Save GCP Points is ticked and Load in QGIS when done is ticked. The corona imagery does not have a grid, unlike the maps, so we're going to have to create ground control points using similar landmarks on the corona imagery and the satellite imagery. You could also use this method for a map that didn't have a grid, or for any other aerial imagery. Firstly, we're going to add one point in each corner of our corona image. So starting with the top left-hand corner, slowly zoom in on both data sets to find a ground control point in this area. Different landmarks are suitable for this depending on your area, but a good option is where wadis join other channels, or where two old roads cross, or if you're in an agricultural area, where old field boundaries cross. So I'm going to use this point here, where this wadi channel joins the main channel. So to add a ground control point, you click Add Point, click on the corona image, and then rather than filling in coordinates because we don't know them, we're going to click From Map Canvas. So we click there and then click on the corresponding point on the satellite imagery and then click OK. You can see a red point has appeared on the corona image and on the satellite image, and a point has been added to the ground control point table. Repeat this in each of the four corners of the image. You can see that I now have one ground control point in each corner of the image. Now that we have these 4 points, QGIS is able to estimate our position using them. To make use of this capability, we click Link Georeferencer to QGIS and Link QGIS to Georeferencer. Now, when we zoom in on one, it also zooms in on the other. However, these calculations aren't perfect, so in some cases you may need to unlink in order to get the point exactly right. In order to make the process as accurate as possible, we need at least 40 points spread across the whole image. It is best to concentrate on the edges with just a few points in the middle. However, after we add 10 points, we can make the process more accurate. So, as you can see, I now have 10 ground control points spread out evenly across the image. You will have noticed when you added points that red lines appear next to them when you add them. These show the difference between where you have placed the ground control point and where QGIS thinks the ground control point ought to go. You will notice in the ground control point table, the last column, residual error, shows the length of these red lines for each point in pixels. But for this resolution of corona imagery, this is roughly equal to meters. So you can see some points are 360 meters out and others are only 120 meters out. Down here we can see the average figure, which for this piece of imagery and these points is about 300 pixels, roughly equivalent to 300 meters. We want to try and improve this as much as possible. Adding points will help, but we can also change the model that QGIS uses to georeference to make it more accurate. So we're going to try that now that we have 10 points. So click on Transformation Settings, and under Transformation Type change Polynomial 1 to Polynomial 2. This just allows its QGIS to use a more complex mathematical model to calculate the georeferencing. Then click OK. You will notice that the mean error has dropped from nearly 300 pixels to 40 pixels, which is a considerable improvement. As we add more points, this should improve further. A georeferenced corona image of this type should have a mean error of less than 80. We need at least 40 points for each image, so carry on adding points until you have 40. I now have 40 ground control points. However, before we run the georeferencer, we want to check that our points are of high enough quality. Luckily, there is an automatic way of doing this. If you look again at the residual error column, you can click on it to sort. If you click once, the low error points go on the top, and if you click again, the high error points go on the top. And as you can see, one of the points has a much higher error than the others, so it is well worth checking this point to see if you need to adjust it. The easiest way of doing this is to zoom in and then right click the point and select Recenter. And as you can see, this ground control point is using the wrong WADI. So we can either delete it by clicking the delete point and then clicking on it, or we can move it by clicking the move point and then dragging it to where we think it should be. And as you can see, that's made a big difference. It's well worth checking all the points that are over 100 pixels. So I'm going to check this one. But I'm happy with it. It looks okay. So then I'm going to check the next one. But I'm also happy with this. So we can now go on to the next stage of the georeferencing process. Now that we have a large number of points, however, we can do one more thing to try and increase the accuracy of the georeferencing. As you can see here, my mean error is 50 pixels. If I select transformation settings, I can change transformation type from polynomial 2 to polynomial 3. This allows QGIS to use an even more complex model that requires a greater number of points. And then I click OK. And as you can see, that's decreased the error from 50 pixels to 42 pixels. Depending on the accuracy of your points and the number that you have, doing this may actually increase the error. So make sure you use the right transformation, either polynomial 2 or polynomial 3. Now that we're happy with the ground control points and with our transformation type, we can click Start Georeferencing or File, Start Georeferencing from the menu. This may take a minute or two. And once it's finished, it will add our new corona image georeferenced to our map. We want to close the georeferencer to remove these ground control points that we no longer want on our map, but before we do that, we should check that we're happy with the result. So zoom in and check that you're generally happy with the georeferencing process. Because of the nature of the imagery, it will not be possible to make it absolutely perfect, but if there's generally good agreement, such as in this image, then we can be happy. So once we're happy, we can close our georeferencer. I'm going to undock it first, and that will leave us with just the image. However, the problem that we now have is that we have these extra black and white areas that we don't want on our image. So I'm going to show you how to remove them. We're going to do it by clipping away the areas we don't want using a shapefile that we're going to create. So the first thing we need to do is to create a shapefile by clicking New Shapefile Layer. Click the Browse button, and in your Corona Imagery folder, give it a name such as Clip Area and click Save. We want a polygon and we want the Project CRS WGS 84. We don't need to worry about the attribute table, so we just click OK. Then in your Layers panel, click on your new shapefile, click the Editing button, and click Add Polygon Feature. Draw carefully around the area that you wish to keep. And when you're finished, right-click and click OK. If you want to make any minor adjustments, you can use the Vertex tool to move any of the vertexes that you're not happy with, like so. When you're finished, click the Editing button and click Save. To cut away the areas we don't want, click Raster on the menu and select Extraction, and then Clip Raster by Mask Layer. For the input layer, select your Corona image, and for the mask layer, make sure your clip area is selected. Tick Create an Output Alpha Band, and tick Keep Resolution of Input Raster. Scroll down, and then near the bottom, next to Clipped Mask, click the Browse button and click Save to File. Give your new file a name. I'm going to use the old name and just add clip afterwards. and then click Save. Then click Run. This may take some time, so be patient. When it finishes, click Close. Make sure you're happy with the result by turning off Clip Area and the old Corona image, and checking that no unwanted areas remain. Just like with the map, you can now use this imagery to digitize archaeological features. For example, this old irrigation system here. Have a go at georeferencing one of your downloaded Corona images and digitizing some of the archaeological features that you can find.